but it doesn't mean that agile may not fit to this amount. It is some other agile methodology that it fits to this big amount of the developers or software engineers. I will show this in the later presentation. So we need this. We should think about, and then if you when you manage your the organization, if the methodology not fit to the amount of the software engineers, that's maybe the problem to manage. I have example of a company, um, but I will not say what's the name, but that company has, I think, more than thousands software engineers, and they use Agile. But then they found out that the Agile doesn't work well or doesn't fit to their way of working. So they are back some part to the waterfall. And people has this is the big surprise as well in industry. Uh, but uh, but then the issue is that Agile has a good way to decrease time to market for the software development. But that company has been using is the cycle was very quick and too quick. And what's happened? The software quality decreased when they released the software to the market, and they found out that when it's too quick, they lost the control of the software quality. So some part of the organization need to be back to the waterfall, but then some parts still stay on agile. So this is what I say that is a dynamic and always the software process improvements that our process may not be the best. It may be best once at a time, but later on, it may not fit to the company any longer. All right. And not even the methodology that we need to think about the size of the company, the stakeholders, and the resources. It should be considered as well. The stakeholders in this case, I mean, like if you have the testers, the role testers, the roles developers, the business analysts who fixed who fix the software requirements. And do you think if we have maybe need to test more than 1,000 test cases, do you think 10 testers enough to do the manual test in 2 weeks? That I don't think is correct methodology. So sometime in this amount of the testers, we may need automation to do the test instead of manual test one by one. And I already showed this question, but I would like to ask, do you think a robot grass cutter, do you think how many test cases that they need per model? This I found in the internet. This is interesting. It is more than 1,200 test cases per model that they need the test case for just as a robot grass cutter. And if you have seen, it's a small one, but required a lot of testing case. All right. Um, not and then we also need to think about delivery time plan and market opportunity, because some products we need more frequent for the software download. You think about your iPhone or Android, how many times you do the software update per year. I believe that is more than once a year, right? But then some products may require less software updates if it is more complex. So that's depending on the market opportunity, complexity of the software to develop, because you don't develop something from scratch, as I said, because you don't create a product, develop it, and just sell it, and you don't maintain it. That is not the good way to have to run the business. So you need to have maintaining for your software as well. So then you don't work with something from scratch, but you work with something exist and you already have a design. So if your system is more complex, and you may lose the opportunity in the market to update it more frequent. So you need to think about and develop and manage to have it on time. And then your life cycle is also important that you need to think about when you like think plan for the software delivery or deploy per year, or the frequency of the software download for the customers. Because when you run one software download, meaning that you run the whole process again, requirements, you remember, development, verification, deployments. So these meaning it consumes the same resources, the same time. And until so if you have 4 times per year for the software download, you need to run this process 4 times, and it's consume the resources 4 times. So you need to think about its availability of your resources and the amount of the workload for the software release. All right. Um, I have a question. What do you think about the communication? Have you in the software life cycle that you have studied, you have learned, and I think, what do you think about the communication is important to an organization? Anyone will volunteer to talk about the communications? No, very quiet. Don't be shy. All right, then we can be through it. Um, the communications is always important, very, very important, because if you want to manage one software business, you need to communication within your team. Like if you have, depending on how you manage your organization, if you set up a developer as a team, then the developer need to talk to each other, because developers need to, I don't think one developer can manage all the functionalities for the software. So in the functionalities function level, we have the subsystem levels and the system levels, and they need to communicate, to talk to each other, and manage how they put the functions in the system. Imagine when you build a city, and the city said like, okay, we need to have a fire station beside a lake, because once something happen in the city, you need to have enough water to like stop the fire. But if they don't communicate when create a city or build a city, what's happened? They may put the fire station beside a mountain instead, right? So the communication is really important within the team, and even between teams, that you need to talk to each other. For example, you have the the management level in the company, right? And you have um, management level, and you have like a middle level that maybe break down the policies. And from the policies, we have, okay, what we need for the product. So we have the project level, we have business analyst level, and we have the team level. So it's so different level that we need to, and if those level in the company don't talk to each other, do you think that we can manage well in the business? In my world, that is not possible at all. You may fail in the software delivery. You may deliver the wrong product. All right. The software process continuous improvement. As I mentioned that no software process is perfect at all. So there is no the best software process. It is only the software process that fits to what you are doing at that time. But it is, you will always find a gap. You will always find what to develop and improve. So you, and then you need to improve your software process all the time, because as in the previous session, if you remember, I mentioned that it is important to have, uh, you will always that change the technology, or not you, the markets, or something you cannot control that may be changed, then you need to improve your software process. And when it comes to verification and validation, in the previous session, we talked about the process and more a little bit in theory, but in the real world, you need to prioritize. The one is the mandatory first. So the mandatory requirements, you need to start to verify or validate that requirements first. Like in some business, the safety is very important. You need to um, verify that first. You need to verify the requirements that related to the regulations. You remember the regulations, and it must be always the buffer time between the test and the release. You cannot test it this week and you release it next week. And how can we ensure that the software that we test the first time is good enough? And in my experience life, I never seen that happen, that is pass the test at the first time. So you will need some time to fix the software, that to fix the bug that you found before the release. So it needs some buffer time to at least to be back to review the requirements, to fix the code, to verify it again, right? So then in the verification and validation, we must also ensure in the real world that we have the correct test objects and test environments. Because then if you don't have the correct test environments or test objects, meaning that you may not have a good quality control in your software production. All right. And when we organize our software release, I would say that in the real world, we will, in many times, we cannot control the quality of the software, and many times we have the hard time to say the software is good, and we may question what's happened if we release these in-quality software. What will be impact? What is the consequence? So if you have that concern, for example, in the real world, I can, since I'm from the automotive industry, I would give an example from the automotive industries. We have a vehicle, a company have sell the vehicle and they developed the new functions in the vehicles and released. And then once the software engineer found, oh, these we found our safety functions doesn't work well. Do you think that you can release that software? Any opinion? A question to the students. Do you have any opinion? Should we release that software? Any volunteer? No, so quiet. Okay, so let's continue. Um, I would say when if that software engineer has a role as a release engineer or release manager, we need to think about what is the consequence of that release. If the software in the customer's hand, what will happen? What is the best case that can happen? What is the worst case that can happen? So if you foresee that is more severe after you release the software, the idea is the delay the software release is better to release something that you are unsure. Because if you release something and that may fix some issue that you are facing, but you face and you create a new issue for the customers, that is not a good idea. So if that software the customer has currently doesn't really severe, or you know that how you handle the situation, you should not release something that you are unsure. So to delay the software release is better to release something on time, and you decrease the customer satisfaction for your software. And everyone, I mean, not just the software release engineers or the release managers, everyone who is the part of the software development, if you see this concern when you do in the software quality in your part, you must raise your hand and say, this doesn't seem right, and discuss within the team instead of you are waiting until the end of the software that will release next week and discuss. That is too late. So everyone as a stakeholders need to have the questions if you see that thing not doesn't look right in your view when you developed the software. That is important. And as when we back to the previous maybe 2-3 slides, we talk about the communications. This is the big parts, and communications is a big part of the software development. We always need to talk to each other. And what's happened if you release a bad software and you feel like we can go ahead, it's just we need it. In the best case, you may found that okay, some functions may not work as it should, but it's not severe, and may some functions that need mandatory may stop working. That is the next step, or the customers may need to not be able to use that product. For example, when the customer has a problem like in the vehicle, customer driving. After the software download, the brake system not work as it should, and that function has requires certificates due to regulations. Do you think that that car can be driven? And the answer is no. We cannot drive that car because, due to the safety reason, and that functions break the law, not follow the regulations. This is people may concern how the software can relate to the law or the regulations. This is one way that and one example. And the company may need to pay for the compensation for the customer in case if some defects. The company may need to call the customer back to the service and do the software update and fix. As like many times you have heard like some company call the customer back, like vehicles, they found like something wrong with the airbag, call the customer back to the service and then do the fix and change the parts. And that is the cost of the company to pay. And in the worst case, you may end up in jail or in not jail, sorry, in the court, and the company may be fined, or maybe sometime the company's management level or the CEO may need to end up in the court. Yes. All right. So need to be aware of your software quality always. And the most important thing, if you have released something not well quality software, the quickly react with the wrong software or the bad software is the more quick that you can solve the issue for the customers. And then we need to react very quick when you get the feedback from the customers of found it is not the good one or it caused severe for the customers regarding to the software release and need to fix it as soon as possible. This is very important in the software business, and this is something that you need to have in the software process when you have this real situation. And I can say the situations can be different for each time. So then you need to think about it, how you will react it, and you need to react quickly due to the situations. For example, you have the software download for the customer over the air, like the music streaming application, and you found that it stopped streaming the music. Do you think that is severe? The customer pays subscriptions. Do you think they are angry when they cannot listen to the music? And that is something the company need to take action very quick based on this one, and fix it very quick. You need to be able to revert. Is it possible? Revert to the previous version and release it again, or you can do the bug fix. So no matter, this is something that you need to define in your software process, and this is the real action that you need to live with it in the and as a software engineer life, and this cannot be changed. All right. And when we talk about the big enterprise, and as I mentioned in the previously of this section, that agile for the enterprise, this is one methodology that we use in one approach that use in many big enterprise, I can say. As I have heard in Sweden, at least the tech company, the enterprise level, using this methodology is called a scaled agile framework. And as you know, the Scrum, we use a small group, but in this case, we apply Scrum to the big organization. In short, I can explain. This scale, this is you will have the link here as well. So, Dr. Abhisheka, you will get the files after this session. So, in short, we have the very high level in the policy level or management level. It's called the portfolio leadership. And in the portfolio, we have it's I can say it is in the policy level or what directions the company should be in that at that time. So from that portfolio, they break down that to break down to projects. I don't see an enterprise company has one project for entire year, so it may be different projects. So from the direction of the company, we break down to EPIC, that is the project. And then the projects, we may not call project manager any longer. It may be called another name to manage that on that EPIC. So then per each time in the project, we managed into this level. It called Agile trends. So that EPIC break down to different per system, I can say. You may have the brick system as like with if we for example the vehicles, we have the brake systems, we have the functional safety system like airbag, right? Or the collision functions safety, or you have the powertrain functions that power to the vehicles to be able to drive. That will be break down to this system, and from that system, from this level, we call the trends. It will be broken down to each team to develop like a subsystem in a smaller, and now we will break as to into like a feature or functions per each group. So this is how, and then we apply the Scrum in this level. And this is like the very short. Any question? I don't know if it is confusing for you regarding to Agile approach or Scale Agile framework. No, very crystal clear then. But please raise your hand if we have time at the end of this presentation or any questions. All right, this is the next is my favorite because it's my expertise. Um, I would like to give example in automotive industry, and that may meaning cars, trucks, buses, or any off-road vehicles that we can drive it. Anyone want to give example why what is the difference between the software in automotive industry and in the normal software world, or the software that you know like application on the telephone? Do you know what is the difference? Anyone want to volunteer? Okay. The difference is the automotive industry, mostly we have the software type called embedded software. Have you heard about embedded software before? It is a software that you have with a machine or command the machine to do some activities, not just on the telephone. So,
It's some kind
yes,
of embedded OS, right?
yes, yes. Yes, you have that, and then as your telephone, you have the embedded in your phone, right? That is the level, and we will be back to that level. That's good example. All right, okay. So now embedded software, what is that? You know, a control unit. Have you seen the PCB boards, like a green one, the computer? That is one of the part of the embedded software. It can be a control unit that you have with a washing machine in a car. It can be a vehicle, the software vehicle. It can be a software that control the sensors, like in an oven. You have one, if it reach to the time that you already set for the oven or reach the temperature in the oven that you set up, it will alarm. It will be alarm. So that is also the software in the washing machine, in your smartphone that you mentioned, right? In the iOS, in the smartphone, or even in the robot that we use in the factory. So the embedded software is in your life everywhere, in the components, in any hardware you use. It will be the embedded software. It will be part of your devices that as a hardware, I can say. All right. So, so next, when it comes to the automotive industry, do you just guess? I would like you to guess. Do you see how many sensors at least do we have in a vehicle? Anyone want to give example? Is how many sensors do you think? It can be speed sensors, can be the sensor to detect the temperature. Oh, okay, then I'll show you. At least it can be 50 sensors per system. Is that a lot? We don't say per the whole vehicle, but per systems. You may need to have the heat, the sensor to detect the heat, and it maybe not one, not enough. You may need the sensors for the speed. It may be the sensors for um, what to say. It's kind of like the pressure sensors that use in the brake systems. So I can say more than 50 sensors at least in a small vehicles, and it's more in the bigger systems. And so the software process in automotive industry, we have in automotive industry, we have the sensors level, we have the subsystem level, we have the system level. So for example, we have the brake development as a sensor at one systems. We have the safety functions, one system. We have gearbox system. So the software process will be applied and be organized in those level as well. And when we wrap up those system, maybe you get one control unit, for example. So you have one control and one system, one control, meaning you may have more than 60 control units in a vehicle. A control units in my meaning means the electronic control units that it is like a computer like you use today, laptop. So it is like one laptop per control units. And then it will control each systems. It will communicate to each other in the vehicles and also control, like for example, brake system. What's happened if the wheel heat has been over the limit, or the it is too quick to drive, or what's happened if there is a sensor found some object ahead in 100 meters, what the brake should react. So this is the control unit do. So when we wrap all the control units, you will get of vehicles that have all the hardware assembly into that vehicles. And these all layers, we apply the software process and manage it, as I mentioned previously. And if you remember, the absolutely process that we use, requirements, developments, verifications, and release. And this is, you will apply this all to each steps. You may need to release, may call internal release to the next step. It not need to release to the customers always when you are in a big enterprise. So you may release from one team to another team. It's like a gateway, ensure that what you deliver to the next team is good. So you release one to another, not need to be always for the customers. And this is like a very general overview of the automotive, how we manage the system or manage the layers in the automotive. And this is what I am working with. All right. And then when we talk about automotive, you remember the regulations? We have a lot of regulations about that related to automotive. And I don't give up to ask you what regulations that do you think that we should think about in the automotive world when you produce a vehicle? What regulations you need to think about? Any opinion or any inputs that you want to provide? No? All right. We need to think about what the service and standard that we need to think about. In automotive, do you think what regulations say about the service? We need to handle the customer service up to 15 years. That is regulations for at least the trucks that today. And the software updates may be longer than 15 years. So imagine how many times that you need to run the cycle over and over for the software downloads, and how for more than 15 years. You need to think about the environment regulations, the safety regulations that you may need to have the software implement the functional safety software that should be certified by some organizations. What is the local regulations that we need to implement? For example, in the telematic systems in Latin America, they don't allow 5G, but we have 4G and 5G in European markets. So the functions are different in different part of the world. And what ISO standard that we need to apply to the automotive industries when we developed the software or the systems. So this is here we need to manage. Then we need to have these to implement in the software. And when we talk about the software design or in the automotive industry, this is fun. It is not just embedded software, I can say, in the automotive industry. And this is we have in this. Yes, someone raise your hand.
Is the ISO is stand for International Organization for Standardization?
Yes, kind of.
Oh,
I am not working with ISO, but it is. Yes, I think so.
okay.
Yeah. I can give an example that we have some, and it's so many ISO, and one ISO that's in automotive industry using is 26262. That is the standards that we use when we do the software design and the functional safety. And functional safety is one of the standards that automotive need to follow. and it's to be the ISO, I can say, is more policy level, but when you apply ISO into the company, you need to break down it into the action level at the end. So it's like you have the policy, you break down to um, like a project level, like plan, and you break down to what activity we need to perform for that ISO. Yes. Mm? All right. Then we come to the design. When we come to the design in automotive industry, and as I say, it is embedded software, and in our vehicles, I can say all the vehicles use these systems in the design. So all the vehicles, we don't have only one control units. We have different. So if in the previous slide, it is like 50 maybe control units at least in the vehicle. And then these control units talk to each other. How they talk to each other? Through the CAN bus system. I'm not sure if the student learn C language already, Dr. Apishaka?
I mean, yeah, okay, it's here.
Yeah.
We studied like a Java, like based, object-oriented programming, and then yes, for those who are interested to learn more languages, they can learn by themselves. And I think the C is also one of them.
Yeah. Okay. Then thank you for the answer. So C is the basic when we talk about embedded software or low level, because yeah. And in general, CAN bus is like the road or infrastructure for the control unit in the vehicle to talk to each other. And in that, it will be once they talk to each other, like we say, control unit is a community. They need to have dependencies, like you have relatives in your life, or like each control units may have dependencies, like they are relatives as well in the simple, and then in the and the platform and compatibility for the functions that important as well when we do design. And then I will explain a little bit for the layer of the software, embedded software. I know that the time is soon up, but I will try to quickly wrap up soon. Yes, so we have the software, embedded software, we have different layer. And in a control unit, and even in your smartphone, it is called the basic software. And basic software in this case, when it's smartphone, it's just one systems or one control unit mostly. So it doesn't matter. But in a vehicle, this is matter, because the basic software is something that it is very low level. It is not Java. It is not C++. If you think about what is that called? The binary. That is in the binary level. So you have 1 0 0 1 1 1 0, and that is the level that you talk about. It is the address of the hardware, and the hardware talk to each other. And what state, if the control unit, it should be in the sleep state, it should active state, and this will define, say, when the electronic control unit need to talk to each other. And in the higher level of this basic software, it's called embedded software. The embedded software is something that, if you have heard about diagnostics, about the software download, this is also embedded software. You download iOS, this is embedded software. You have read out the fault code from the unit. This is embedded software. And when the sensor doesn't work properly, this is also the embedded software to detect. So this is something embedded software to say some machinery or sensors to do something or take some action for the hardware. And then we have application level that you know as like application that when it comes this input, if it is too high heat, what to do. So this is the level, this is in the application level. And embedded set level will kind of like will be the foreman to say, hey, you do these activities for the hardware. And I hope that this show you overview of pictures of the embedded software. All right. So when it comes, yes, and then after embedded software that we design, we produce the trucks. We need to think about the compatibility between the software and hardware. And as I said, we don't stop just developed one product and sell it, and that's it. We need to leave this product. And in automotive industry, we need to leave like more than 10 or 15 years for the updates. And the hardware need to be compatible to the vehicles when it comes to the service. For example, we have the production, the truck in the production and build with the hardware one here. And then many years pass, we have the new software release all the time, and the hardware for sure update due to the functionalities and so on. And once maybe the hardware one is out, or like end of the production, then it is no longer produced in the production. And later on in the version 4 that currently software that the company released, the vehicle come to the workshop and want to do maintenance and found out that we need to exchange the hardware. But hardware are no longer valid. So they need to exchange to hardware 3 instead. And in this case, it must work well. And for the trucks, even they built like 10 years back. So this is one of the picture of the backward compatibility with the but this is how we apply the hardware with the software. Why hardware is important, should be compatible with the software. It's about, if that hardware is about the software is the control unit, and that is the platform. If that hardware platform doesn't contain to the software in the trucks, that fail for the company. So this picture is showing how, or clearer and more explanation with the backward compatibility when it comes to the hardware. All right. Any question to this slide? I know it may be confused you a little bit when it comes to the hardware. No? Yes?
Okay, I think that is the questions related to what you have said is in the, yes, I mean, I tried to read it, but I don't know where
In
is
the chat?
Yeah, in the chat. I cannot
Yeah.
open my my chat
Yes.
right now. I mean,
Yes.
I try.
How do we know that our product is in or not enterprise brand or not, and how do we know the software quality when the customer's requirements didn't cover the quality scope for us? These we need to have it in our requirements from the beginning. And if we do not have these in our requirements, meaning that we fail when we create our requirements. So the customer requirements must be already in our requirements, I can say. And okay, that our product is in enterprise. I don't understand this question. Can you clarify? If do you mean that if this product is an enterprise or not, right?
Maybe. I think so. I just think.
Okay. The enterprise more the size of the company, I can say. So if you think if you want to know if this product can be the enterprise or not, is so it's mean the budget of the company, and also if the company is global and that your products is high value, the market value is big, then it can be enterprise. I'm not sure how much value of or the value of the company should be an enterprise, but if I can say in general, it can be if you are a global company, if you can, it is that you have in many base. Like for example, CP in Thailand, that is enterprise. And if you have, it is like Toyota or Honda, that is enterprise product. Yeah. And also even we talk about, I'm not sure, but I'm not sure about Spotify is an enterprise, but I am not really sure about the like a Spotify. But if we say like Volvo is an enterprise because it's many country based, because the Spotify have very less limit information about the company. The standard policies is if we talk about the policy I mean is the policy in the company, not in the public. So it's more the standard in your company or in an enterprise, because enterprise you talk about 10,000 or 5,000 employees. So you need to have a policies to say, okay, what direction the company should be, how we should be as organizations, for example. All right, I would say I have my 2 minutes left for myself. I have 2 slides, but I will be very quick and we can come back to the questions. All right, after the compatibility for the hardware, the difference between the pure software organization and the embedded software for the verification and validation is you need to apply the hardware in all elements that you do the test. It can be the component level that you want to test, the hardware components and the software together. So but it's the same step as in what you know about the testing. Is like a single unit testing, system testings. You may have the simulation testing or complete systems testing. But instead, in automotive, you have the components, hardware with the hardware, and the system requirements for the brake elements or brake components, and then and also brake system, brake functions. And sometimes you may not be able to test in the real vehicle. We call rig testing. We have the hardware control units exactly the same as in the vehicles, but that cannot be driven, but the system still work in the simulation world with the real hardware. And at the end, you may need to test in the real vehicle driving on the road with your software. And then you can produce a test report for all the layer. Yes, and the last one, I would like to give you this clearly again, that you always need to improve the software planning or software or the process in your organizations. And this is a cycle that I'm writing, that we have the planning software process, we implement our process into organization, we organize our organizations, and then we found a gap in our software process, what need to be improved. Oh, this doesn't work well, doesn't cover this. We found a fault, the faulty, and this we cannot cover by the process. Then we need to improve our process. And after we improve it, we write it down as a process again. And then it will be this cycle over and over. You cannot be end with your software process or your software planning, and you need to organize your plan and change it when that dynamically. And that is all that I want to show you today. And I know that we have 4 minutes left. Any questions or anything you want to provide input or feedback Please, yes, Ratchanon.
Yeah. I remember last week you say that software delivery always late or something. I
Yes,
have a
yes.
question
In the
that
real world, yeah.
yes, as a leader, as a manager at the time, if you know that your product gonna be submitted late, what should we do
Yes.
at if we is a manager?
Okay. First, we need to define what in which level is late, and then we need, if we figure it out very late, that okay, it soon will be very late, and then too late to do something else. We need to check what first define what is the consequence if we are late. For example, if we have the factory with the hardware, we need to define what is the consequence, what will be happen, and talk to that department or group that may impact due to this late, and replan everything again in short, and as soon as possible need to release, but that based on when we back to this slide, we do not release anything that is not good enough or that create a new problem. So if we delay, we need to replan everything, try to define what is the consequence, replan it, and try to manage it. And you need to have like it's kind of like a task force that you need to hot fix together and try to push it. So you need to need to have overtime to work with that due to the new plan. So that is what we can do the best, but that is applied based on situations. And that is a good question. And in the software business, it's always, I can say 80% late software delivery in my experience. Yeah.
Yes, thank you.
Thank you for the question. Anything else? Anyone want to provide your feedback? You can also say like, oh, this is, I can
So
improve this. Yes.
so why don't you test on production when you don't want it to be late? I'm just
We
kidding.
we don't taste in if you say in the factory, we don't taste it there, but we taste it during the development. Is that what you mean?
Yes, I think he also asked like why don't you do the test on production? Maybe it's just like
And we
I
back
mean, yeah.
to when then we back to you need to have a buffer time. You remember when I said between testing and release. So if you don't have that buffer time, the hot fix always leading to the risk that you may face another issue that may be to create a bigger issue. It costs the company then because the hot fix or in the production that may lead to some fail in the software download or for the customers. So something you have it's very shorter than your cycle time. That's always the risk. So that's why we don't do the test in the production. Mm, Yes.
I appreciate it.
Yeah. Thank you.
Yeah. You have more questions? Everything is
Uh,
very relaxed here, right? You can
yes.
ask.
Yes. So please ask, or if you have more questions afterwards, send also send. You can also send the questions through Dr. Abhisheka, and then I will be more welcome to answer. Yeah.
Okay.
Yes.
Can we have
Rashanon.
the presentation slide?
Yes, you will. You will get it. I will send
Yes.
by today evening. I will send it to Dr. Abhisheka, and she will. I think you will distribute to the students.
Mhm. Okay, if there is no more question, I will wrap up a bit because so that is what I really like. Our guest speakers, พี่พิมพ์คุณสายพิรุณนะคะ She also mentioned that okay, and then what we are going to do in organizing the software business is we organize to follow the plan, right? This is
That's
the
true.
key takeaway that I want you to get the point. That's why I invited our guest speakers to speak about these two topics because of they relate to each others. Okay, and I want to say thank you again and ขอบคุณค่ะ
Thank you to having me here. Is that okay if I put this if I capture this meeting and then put in my social? Is that okay for everyone, or because it may see your names as well?
Is
It's
it
not
okay
okay
for you?
then. If it's not okay, please raise your hand.
I'm okay. I don't know. I have to show. Do you want to show my face?
Yeah.
It's fine.
No, it's okay. I just
Okay,
like
please
capture that.
take a photo.
Then I do it. And may I use your previous email as well?
Yes, yeah, you can.
Yeah.
I mean,
Okay.
if you are not okay, everyone, you can tell me.
Yeah.
No
I
one.
will have a waiting time a little bit, so no problem.
You take a photo, both of us. No one
Yeah.
wanna be with us.
But then thank you for having and listen to me. Today, and I hope that what I mentioned is something that I can use in the future. Yes, someone want to say something?
Can I say it in Thai?
Yeah.
ผมอยากทราบตลาดแรงงานด้าน security ในแบบสวีเดนนะครับ มันเป็นยังไงบ้าง
Oh, okay.
Okay.
Should I
now-
answer in Thai or English?